Let me start off by saying that if you're watching this video looking and you're struggling with this question, this video is probably not for you. It is I okay, I'm just gonna say it straight. I think the textbook answer is wrong. Alright? So we're gonna be going into like some decently deep discussion. You definitely can learn something from this, I think. But yeah, it's for those of you that are suspicious of the textbook's answer, because yeah, let's say that I think that this answer is wrong. It's just wrong, bad math, and the cause is that this diagram is bad. This looks like a 90-degree angle, but it's not. It's not a 90-degree angle. Let me start by convincing you that this answer is wrong. There are a lot of videos out there on YouTube already that shows you the way you get this answer. And cut short, they assume that this is 90 degrees. But it's not. Why? Because let's say that this is 90 degrees. Then this is the speed that Hamid is traveling in this direction. So he travels 6.47, forgive my handwriting, I'm using a mouse, meter per second for 12 seconds directly upwards, right? 90 degree to the river flow. So this distance that he travels, according to other people's assumption that this is a 90 degree, would be 6.47 meter times 12, which is uh, 6.47 times 12 is 77.64. Already you can see, right, that clearly something is wrong. That's not 40, right? So let's let me show you the real way to do this. Okay? First of all, you should not think of this as a 90-degree angle. This is misleading. Uh Actually, let me reinforce my point as why this can't be 6.47 meter per second in this 90-degree direction, because Hamid travels this much P to Q with the help of the river and his own beat and his own boat speed. So it's without a doubt he travels this much P to Q, and if the only vector, which is the speed of the river that carries him in the x direction of the river's direction, since we are claiming that if this is 90 degrees, then he only moves upwards. He doesn't move like slightly to the right or anything. His boat speed is purely upwards, and the only thing that's carrying him rightwards is the river speed. And if that is the case, then 1.8 times by 12 is not gonna carry him 70 meters. I hope you can understand what I'm trying to say. Yeah, and if you're watching this video, you probably already guessed that. I'm reassuring your suspicions. Okay, so how do we solve it then? First of all, don't think of this as 90 degrees. Let's shift this over actually, so that we don't get confused by it. So since the river carries him, how much does the river carry him? The river sorry, not 4. The river carries him a total of 21 meters to the right. Okay, so the river carries him 21.6 meter to the right. Therefore, he himself must have traveled 70 minus 21.6, right? So like, let's say this much is, no, let's say this one on the left here, this one is 21.6. So this is the one that Hamid's boat traveled himself. This is only for the x-axis. We haven't been talking about the y yet. Oh yeah, the actual vector would probably look something like this. This is his true boat's vector. So he travels some amount to the right and some amount upwards. So now we know this. This is 70 minus 21.6, which is 48.4, right? My mental math is not very good. Yeah. Okay, so this is how much Hamid's boat travels in the right direction. Let me just draw that vector here. So now we need to figure out how much he travels um, in this direction, right? The upwards direction that carries him vertically from P to Q. So actually what it would look like if you were to draw like the triangle of vectors, it would be something like this. Hold on, wait. No, wrong. Sorry. We figured out, okay, this blue one is the true vector that Hamid's boat traveled to get from like P to, what was this point originally called? R, right? This is R. By the way, we are talking about distances here because it's hard to think about speeds as vectors. Distance is easier. So we know that he traveled 48.4 meter in the x direction. We don't know how much he traveled in the y direction. So this is the y direction. We need to find this out. Well, we do know it's 40 meters. So yeah, that's that's it. This is 90 degrees. I don't know if you understand. Okay, yeah, this is kind of all over the place, but like, let me just compute that answer first and show you. So this this blue vector should be equal to 40 squared plus 48.4 squared and all square rooted. So that's what's, no. Oh my god. Yeah, 40 squared plus 48.4 squared. There we go. No. That's too big. 40 squared plus 48.4 squared. Alright. And now I want to square root this. No. This ain't right. I want to square root this. What? There's no way this is right. Like the hypotenuse of a triangle has to be the longest. It Okay, 1640 squared plus okay, you know what? 48.4 squared. What are you? Oh, okay, I see. I have to add 1600 to you, and then now I can square root. Okay, you know what? This calculator sucks. There we go. Okay, this is 62.7. Yeah. So my claim is that Hamid travels a, a distance of 62.7 meters. His boat travels this distance, and since he travels this distance in 12 seconds, his actual speed is this divided by 12. Is that right? I don't trust my calculator. 62.7 divided by 12. Yeah, 5.22 meter per second. Okay. Um I'm gonna try to recap like what I just did. So we know that this river has a downstream flow of 1.8 meter per second. So if he traveled from P to Q in 12 seconds, then that means this river would have carried him 21.6 meters to the right. So his boat would have traveled this distance here, which is 48.4. Just 70 minus 21.6 and 48.4. That's the distance that his boat traveled without the help of the river. But then he needs to get to the other side of the river, like here, and that's 40 meters. So this is the amount that his boat has traveled. His boat traveled 48.4 meters to the right and then 40 meters upwards. When you do that in one swift motion, it becomes this vector, which is the blue one, this one over here, and that's just 62.7 meters. So that's the distance that Hamid's boat traveled. And he did that in what, 12 seconds? So his speed is this. Quite different, eh? Let me convince you that this is the true answer. Um, how do I convince you though? Okay, let's just try whatever comes to my mind. So we know that his boat plus the river traveled this distance, PQ. PQ is let's just draw it out. This is PQ. PQ is 40 squared. 40 squared plus. Oh, okay. I have to do this. What's 70 squared? 4900, right? 4900. Okay. So this 6500 square rooted is this. So his boat traveled this distance. This is with the help of the river. This P, this Q. And now I claim that he travels upwards 40 meter. What? No, 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 no. Okay. Uh, uh, cut, cut. Okay, so how do I convince you that this is the true speed of Hamid's boat without the help of the river? We don't know the exact angle. You can find it if you want using trigonometry, but let's just say that this is the true vector, all right? It's 5.225. This is just like checking our answer. It's some direction, some like this vector is composed of two other vectors, a right side vector and a upwards vector. So this is meter per second. We're thinking about speeds now. Well, Hamid needs to travel 40 meters upwards in 12 seconds. So this is just 40 meter over 12 second. Then this one should be 48.4 meter per 12 seconds. This is the speed of Hamid's boat in the right direction, the pure right direction, and this is the pure up direction. And let's let's add the river to this and see what happens. So if we add the river, this vector becomes longer, the right side vector becomes longer, and now it's whatever this is, 48.4 divided by 12, that's 4.03, plus the river is 1.8 meter per second, and then this upwards one stays the same, it's just 40 divided by 12, which would be 3.33. This is all in meter per second, by the way. I'm just lazy. And then, in theory, if I'm right, this squared plus this squared should give us the speed Hamid's boat traveled from P to Q. Alright, so 4.03 plus 1.8, 4.03 plus 1.8 is this, and this squared is that, plus 3.33 squared. Is it doing it correctly? Yeah. This is 11. Oh, no, 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 no. What? 5.83 squared is almost 36, right? 6 times 6, 36. 3.3, that's 9. Yeah, it's almost is correct. It should be correct. 45. All right. So this squared plus this squared is 45, and square root of 45 is 6.714, which is, this is in meter per second. So we take this and we times by 12. This returns to us indeed the distance that he traveled from P to Q. Where did I write it? I swear I did write it somewhere. Oh no, I edited that part out. Okay, okay. So take note, this is the distance that he traveled according to me, according to my theory, is 80.56 meter, right? From P to Q. This is with the reverse help. And if this PQ over here is 80.56, then I should be right. Okay? So that's 70 squared plus 40 squared. That's this, and the what's it called? The awaited time, the uh I don't know. Alright, 80.622. Yeah, yeah, almost correct, almost correct. Like I'm just off by like point 0.1. Eh? Point 0.1 something. I that There's a rounding error. So yeah, I hope that if you were struggling with this question like I was back then, this cleared up some of your um suspicion, and you learn more about vectors.